equal to 0, Q is 0, Q bar is 1, bead bar is 0, means it is forcefully brought to 0, and after that I am applying right pulse. So when right pulse is applied, again M5 as well as M6 will turn on. Yes or no? It is very simple. M5 as well as M6 will turn on. So when M6 is turned on, what happens? You tell me. When M6 is turned on, voltage at this point is VDD or logic 1. Now this point is forcefully brought to 0. So therefore this voltage, this node will start discharging. So as this voltage start discharging, at one point voltage of this node becomes less than threshold voltage of M2. See here again, back to back connection means what? This node is connected here. It is connected here means it is connected to gate of M2. So when logic 1 is stored here, this means that M2 is on, and as M2 is on, this voltage is 0. But we want to change it to logic 1. Then what you have to do? You have to turn off this transistor. So when you can turn off this transistor, there is only one way: make voltage at this point less than VTN of this transistor. And therefore, what happens basically? You are making this bead bar line 0. You are applying right pulse, M6 turns on, therefore voltage at this node starts discharging towards logic 0. And when voltage at this point becomes less than VTN of this transistor turns off and this voltage becomes 1. Yes or no? And in this way I can write logic 1 in memory cell. What it? How this is happening? Here how I can show? Here how I can show? When right pulse is applied, what happens to this bead bar? Sorry, what happens to this Q bar? Q bar is logic 1 basically. So as soon as you apply right pulse, this node starts decreasing. Yes or no? This node starts decreasing, and when this voltage becomes less than VTN of this transistor M2, then what happens? M2 turns off. I can write here M2 turns off, and as M2 turns off, suppose this is that point, as M2 turns off, then its output becomes 1. Yes or no? Means earlier content was 0 and I am writing 1, means I am modifying the content. So in this way I can write information in SRAM cell. So we have seen how to read and how to write in SRAM cell. This is just operation of SRAM cell, read write operation. But moreover, what you have to do? We have to design this cell. Design this cell means what? From the first lecture I am telling you people that design of VLSI circuit means just finding ratio of width and length of the transistor for each transistor, for this transistor, this transistor, this transistor. So therefore for SRAM cell also, design of SRAM cell means you have to find out ratio of W, that is width and length of each transistor, to satisfy some specifications. Now what are the specifications? What specifications you have to satisfy? Because when you design this SRAM cell you have to take care that SRAM cell should be robust. What is meant by robust? Robust means see, during read operation we should only read the contents of memory. During read operation we should be able to read only contents and we should not modify contents of memory. Yes or no? Sometimes what happens during read operation, it may happen that contents of memory location, contents of that memory gets modified. Then we can say that that memory is not robust. Okay. Similarly, write operation means write operation must modify contents of memory. Okay. And sometimes what happens, even if we apply write pulse, then also contents are not getting modified. So this is called as, this is considered as memory is not robust, and therefore you have to design this memory cell, or you have to find out W by L ratios of all transistors such that your cell, memory cell or SRAM cell is very robust. Means if you are writing something, content should get modified, and if you are reading something, content should not get modified. Okay. So therefore now we will see design considerations of SRAM cell. Design considerations of SRAM cell. Again I will redraw this circuit. Two inverters, back to back connection of inverter from this point to, it will go here. Two access transistors. This is bead bar, bead line, one capacitor is associated with it, that is bead bar capacitance. Here is another access transistor, and this is bead bar. Complement of information is available on this one. Now consider this is Q and complement will be available here, that is Q bar. Again M1, M2, this is M3, M4, this transistor is M5, this transistor is M6. Now design consideration means first is read operation. I told you that you have to find out W and L for each transistor such that during read operation content should not get modified. Content should not get modified. For example, suppose 0 is stored here, 1 is stored, means if 0 is content of memory location, then its complement is 1. Now see, I want to read this. Consider this voltage of this node is V1, just for the understanding purpose what is meant by design consideration. Now read operation, I have to carry read operation. What you have to do? First bit line and bit bar lines are pre-charged to logic 1 and then I have to apply read pulse. So when I apply read pulse, what happens? M5 turns on, M6 turns on. But voltage at this point is VDD, that is logic 1, voltage here is also VDD. So no current will pass through this. What about M5? Voltage at this point is VDD, voltage at this point is 0, because 0 is stored, this transistor turns on and transistor M5 will discharge like this through M5 and M2, yes or no? So during this what happens? Voltage at this point will increase, yes or no? Because current is passing through M5 and M2. So earlier this voltage was 0, during discharge as this capacitor is discharging, this voltage will rise. And suppose if this voltage V1 becomes greater than VTN, that is threshold voltage of M4, now what happens? M4 will turn on. So when M4 will turn on, voltage at this point will become 0. And what will happen to M2? M2 will turn off and voltage at this point is 1. So this should not happen because we are performing read operation. So during read operation content should not get modified. And what is the possibility that contents will get modified? If this V1 goes beyond threshold voltage of M4, then contents get modified. And therefore while designing, what care you have to take? You have to take or you have to find out ratios of width and length of for each transistor such that during read operation V1 should not go above VTN. Means while finding out W and L ratios for these transistors, you have to see that W by L ratios means voltage at this point should not go beyond VTN of M. Now in next lecture we will see how to find out exact values of W and L. Okay, thank you.